nice topic. Today we are going to talk about loss of indices. When we say indices, assuming we have a number a is equals to a raised to the power of 3. So an indices is always a short notation of a number when it multiplies itself a multiple time. For instance, here we have a times a, which is equal to a raised to the power of 3. Instead of writing this a times a, we just write a raised to the power of 3. This type of shorthand notation in mathematics is known as the indices, whereas this number a is called as the base number, and this one is called the index. This 3 is called the index power or exponent. I hope you are following. So we call this number index power or exponent, where this a is called the base number. There are many laws abiding by these laws of indices. We have number one, which is a multiplication law. This multiplication law, we have, assuming that we have a power 2, which is equals to a times a, and also we have a power 3, which is equals to a times a. So if we multiply a power 2 times this a power 3, we are going to have a times a times a times a times a, which is equals to a raised to the power of 5. So when we have a raised to the power of 5, let us consider this relationship between the powers. We have these two, we have 3. If you added this 2 plus 3, we are going to have 5. Assuming we have another example like let's say a power 3 times a raised to the power of 4. We are going to have a times a times a, then times a times a times a times a. When you count it, you see 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 1, 2, 3, 4, 5, 6, 7. We are going to have a raised to the power of 7. So considering the relationship between the powers, you see that we have 3 plus 4, which is equals to 7. So whenever you have a raised to the power of m multiplied by a raised to the power of n is the same as a raised to the power of m plus n. This one is called the multiplication law. I hope we are following. This is what we call the multiplication law. Whenever you have a number which is a base number raised to the power of another number, then you multiply the same number with another power, you just use one of the number which is a base number and then add it the power. This is what multiplication law is saying. The next one is division law. Consider another numbers. Assuming we have this a raised to the power of 3 divided by a raised to the power of 2. This is the same as a raised to the power of 3 divided by a raised to the power of 2, which is the same as a times a all over a times a, which is equals to a. I hope we are following. So let us have another example. A power 4 divided by a power 3. This is the same as a power 4 all over a power 3 is equals to a times a times a times a all over a times a times a. You see that 3a cancels 3a, we are going to have a. So let us consider the relationship between this power. We have this 3 and we have this 2. When we divided a power 3 divided by a power 2, we are going to have a. That means if we subtract 2 from this 3, we are going to have 1. The same is applied to this one. We have 4 here, we have 3. If we subtract 3 from this 4, we are going to have 1. So there is a relation between the power. Look at it. If that is the case, whenever you have a power m divided by a raised to the power of n, you just subtract this one from this one. So you are going to have a raised to the power of m minus n. This is the division law. The power law say, let's assume we have, assuming that we have a power 2, there is the power of 3. This is the same as a square times a square times a square, which is equals to a raised to the power of a raised to the power of 6. I hope we are following. Let us have another example. A raised to the power, let's say a power 3, then power 4. Still, we are going to have a power 3, a power 3, a power 3 times a power 3. How many times? 4 times, which is equals to a raised to the power of 2 of it. We apply addition law. So now, so the multiplication law. So now let us consider the relationship between the power again. Here we have a power 2 multiplied by 3, or raise the power of 3, all of them. So you see that it's just a multiplication between 2 times 3 will give us 6. And if you come to another example, we have a power 3 close bracket power 4. If we multiply the power, we are going to have 3 times 4, which is equals to 12. That means whenever you have a number with a power and the rest to the another power, you are to just multiply the two powers. So if you have a raised to the power of m close bracket power n is the same as a raised to the power of mn. This is the power law, and it is one of the law abiding by these indices. We have 0 index, this 0 index, assuming that we know that a raised to the power of m divided by a raised to the power of another m is the same as a over m all of a power m all over a raised to the power of m. If you apply division law, is the same as a raised to the power of m minus m, which is equals to a raised to the power of 0. But remember, if you divided any number with itself, you are going to have 1. This a power m minus n is the same as 1. Therefore, what does this law is saying? Whenever you have a number a raised to the power of 0, that number is just 1. This is 0 index. So whenever you have a number, be it 1 million, be it just 1, be it 1,000, whatever number it is, if it is raised to the power of 0, just consider that number as 1. This is another example or another law. The next one here we have the negative index. What the negative index is saying, assuming that you have a power m multiplied by a power minus m, this is the same as what? This is the same as a power m minus m, which is equals to a power 0, which is equals to 1. So if you have a power m multiplied by a power minus m divided by a raised to the power of m. This is the same as you already have this one as what? M minus m, the a power m minus m, which is equals to 1. This is the same as 1 over a raised to the power of m. This is the same as a raised to the power of a all over m, which is equals to a power minus m. This is another example. So whenever you have a raised to the power of minus m, is the same as 1 over a power m. This is another law, which is the negative index. So I hope we are through with these laws of indices. The next one is fractional index. We are going to deal with it when we come across the some simplification of the of we are going to deal with when we come to solving of many equation or many example concerning these laws of indices. So if you have any question, you are free to ask me through the message. You can comment through the comment section. You can comment me, ask me whichever of the law that you do not understand. I'm ready to explain. Thank you for following. Thank you for following. Please subscribe because more is coming under this laws of indices and also the logarithm. Thank you for watching.